This video will explore how dual coding can be used to promote learning in the classroom. In order to support learning, it is helpful to analyze the key components of the process. New information is always being presented to our brains. In order to learn, we must first focus our attention on it so that it can be held in the regions of the brains associated with our working memory. If the information is held in our working memory long enough, it gets encoded into our long-term memory. However, in order to use this information, we have to build retrieval pathways to the areas where we stored it. Once the information is back in our working memory, it can be used to complete tasks. If we look at the overall pathway for learning, working memory is central to the process. However, working memory can be overloaded. We have all experienced the impact of an overloaded working memory. That's what happens when you find yourself staring at the fridge trying to remember what you were supposed to be getting from it. Somehow, on the way to the fridge, something distracted you. You lost your focus and the information in your working memory was lost. Or your thoughts were so busy that you could not hold all the information you had in your working memory, and the bit about your trip to the fridge was lost. And we all know what it feels like to be standing in front of a fridge trying to remember why we were there. It is frustrating and confusing because when your working memory lapses, moments in time are literally disconnected for you and it causes mental discomfort. So imagine what it is like for a student whose working memory is constantly being overloaded in the classroom. They are constantly frustrated and confused. And so not only does this negatively impact their learning, it also negatively impacts their behavior. Often students with disruptive behaviors are seen as willfully resisting learning, when research suggests that what is really happening is that they are exhibiting a very natural response to a working memory being constantly overloaded. Their behavior and poor learning is actually a symptom of continuous working memory overload. So to avoid overloading students' working memory, teachers should break their lessons into meaningful chunks, avoid multitasking, and uncouple skills in task execution. Also, it is important that lessons be organized, well-paced, and structured on keeping the learner focused on the learning experience and not on recording the learning experience. Only after the learning experience is done should the student be expected to consolidate their learning in a note-taking process. However, even if working memory itself does not fail, the learner can find expressing their learning difficult if they do not develop or maintain retrieval connections between the information stored in long-term memory and their working memory. After all, what good is storing information in your brain if you can't access it to use it when you need to? Thus, learning requires that teachers generate programs that actively target retrieval pathways to information during the learning process. There are many pedagogical strategies that help to target retrieval pathways. However, these strategies work because they either create multiple connections to the information stored in long-term memory, or they encourage the student to encode the information into multiple areas of the brain during long-term storage. In this video, we will look at dual coding. This strategy allows the brain to encode information in multiple areas of the brain. Dual coding is the strategy best illustrated by memory athletes. Memory athletes compete to memorize random data sets like strings of numbers, decks of cards, and letters. They do this by building memory castles in which they generate a visual construct in their mind that they can walk through. As they walk through the castle, they are able to recall the data because it is hooked to a visual cue. In other words, they are more likely to remember large random data sets by coding the information in multiple forms. For example, a visual and a numeric form, since the brain appears to encode different forms of information in different locations of the brain. If we translate this to the classroom, it means that students' learning is more likely to be retrievable if students generate notes that employ a mix of text and images of their own creation. In addition to employing retrieval, dual coding reduces the reading requirement during studying. This lowers the load on the student's working memory and improves their ability to store and utilize information. Improving students' ability to dual code requires them to practice communicating information in multiple formats. This training is illustrated in a sample activity from the grade 9 science class, in which students demonstrate their understanding of trophic cascades. This activity utilized activity cards from the HHMI Biointeractive website. Students used digital copies of the activity cards to create food chains. Then they generated a prediction on how changes in the top predator's population would likely affect the population of the producer. They recorded their predictions in sentence and graphical form. Links to my files associated with this task are in the video description below. Also included in the description are student exemplars of dual-coded notes at the grade 9, 11, and 12 levels that illustrate what dual-coded notes can look like at various grade levels. If you are a science teacher, feel free to download these files. Once again, I would like to thank all the folks at HHMI Biointeractive for their amazing wealth of biology resources. If you are an educator and this subject matter interests you, please consider subscribing to this channel. I will do my best to make videos on education topics at a reasonable pace. My sincere hopes is that my videos are useful to others and help me to consolidate and reflect on my practice. And finally, if you are a classroom teacher, good luck on your journey. We are all in this together.